Okay, this is section E1.6, which is talking about reducing versus clearing fractions. And I just realized I have a typo right here. This is reducing. Oops, another typo. Reducing versus clearing fractions. Sorry about that. All right, so when we have expressions, which means that we just have a statement, not a this equals that, just an expression without an equal sign, the only thing we can do is hope to reduce it by canceling common factors. So when you're given an expression, if we have more than one term, we want to make it one term, and then once it's one term, we factor the top completely, we factor the bottom completely, and we just reduce common factors. So let's look at a couple. On this one, it says simplify the following. I want to factor the top and bottom completely. Looking at the top, my common factor would be 3x. So I'm going to go ahead and factor out 3x, which would leave me with, remember when you factor it out, you divide it off. So 3x divided by 3x leaves me with a 1. 6x squared divided by 3x leaves me with 2x. Okay, and then that's all over 3x. Now that I have something completely factored on top and something completely factored on bottom, now I can cancel common factors on top and bottom, which here I can cancel my 3x and my 3x. Okay, which leaves me with just 1 plus 2x. Not too bad. Let's look at another one. This next one, same idea. I'm going to go ahead and factor the top completely, factor the bottom completely. In this case, the bottom one's factored completely. It's just x to the first power. Now the top, in order to factor this, I'm going to do sum product. When I do my sum product chart, my sum is going to be my middle coefficient, which is 5. My product is my first coefficient times my constant. So 1 times negative 14 is negative 14. So I need something that multiplies the negative 14 that I can combine to get 5, which would be 7 and 2. And I need it to be negative. So one of these has to be negative. So it's either going to be negative 7 and positive 2, or it's going to be positive 7 and negative 2. In order to get a positive 5, which is what we need, we're going to take this pairing right here. So we're going to do 7 minus 2. Now, remember our little shortcut that if our leading coefficient is a 1, the values I find in this chart are the values inside my factored terms. So that tells me that this top piece is going to factor into x plus 7 times x minus 2. Okay? And then on bottom, I'm left with x plus 2, which is stinky because I wanted those to cancel. So we're going to call this a typo, and we're going to change this bottom one to a minus. Let's do that really quick. I'm sorry about that. Let's say this is going to be x minus 2. We're going to change this, because otherwise we wouldn't have been able to do anything. It might have been my typo when I was typing these up. Okay, so now miraculously we have the same factor on top and the same factor on bottom, so now we can cancel those, which leaves us with just x plus 7. Okay, makes sense? Once we've finagled it. Okay, let's look at another one. This next one, even though it looks kind of nasty, it's actually really nice because it's already factored for us. We need to look at each little factor to make sure each little factor is completely factored, but if so, then we can just start canceling. So notice on top and bottom, all the quantities that I see, all the little factors, have x to just the first power, other than this coefficient on top. Okay, this term on top that's just an x squared, because it's not being plus or minus to anything, it's completely factored. So now I can just start reducing. So I'm going to go ahead and rewrite this just so I don't make the original problem messy. All over x times x plus 2 times x minus 3. So the common factors that I see is we have x's on top and bottom. So I can cancel 1x from the bottom, which leaves me with no x. If I cancel 1x from the top, that leaves me with just x to the first power. And then I have the quantities x minus 3 in common. So what's left over after I do my canceling is the 1x factor, and then the quantity x plus 3, and then on bottom I'm left with just x plus 2. Okay, and on a test or in my math lab, if there's no factors being multiplied times a quantity, you don't have to put parentheses around the quantity. So you could enter this in my math lab as such, or you could just put x times x plus 3 all over x plus 2. Okay, we don't need the parentheses if there's not a factor out front of it. Okay, all right, so that was just reducing. Okay, now when we talk about clearing fractions, we can only clear fractions or get rid of them completely if we have an equal sign. So again, I'm going to go ahead and fix my little typo here. This is supposed to say reducing. In the event that we have an equation, which means we have an equal sign, we can get rid of all our fractions by looking at all the denominators of all the fractions and finding a common denominator. Now, most of the time when we find a common denominator, we want to write everything with that common denominator so we can add and subtract things. But we're going to use the idea that if it's a common denominator, I know that all of my denominators will divide into that. So what I'm going to do is I'm going to multiply every term by the common denominator so that I can reduce it, so that I can basically cancel away my fractions. Okay, so let's look at one. First of all, I need to find what would my least common denominator be. So looking at this one, I look at all my denominators. My least common denominator between 4 and 5 would be 20. And then this last one, I have a t. So I need a t on there too. So my least common denominator for this one would be 20t. Okay? So I'm going to go ahead and multiply every term by 20t. So 20t times 1/4 plus 20t times 1/5 equals 20t times 1 over t. And the reason I'm doing that is because now notice all of my denominators will cancel away. Because on the first term, 4 goes into 20 5 times, which leaves me with 5t. On the second term, 5 goes into 20 4 times, which leaves me with 4t. And then on the other side of the equation, my t's will cancel, and I'm left with just 20 times 1, which is 20. Okay? And now I have something that's easy, much easier to solve. I combine my like terms. 5 and 4 gives me 9t is equal to 20. And then I divide off that 9. Okay. Again, I didn't specify here whether or not to leave it as a reduced fraction or as a decimal. Since I didn't say round to the nearest whatever decimal place, I'm going to go ahead and just leave it as a reduced fraction. Here, 20 and 9 have no common factors, so I'm just going to leave it as an improper fraction, 20 over 9. Okay, let's look at another one. Oh, and I probably should note, we're going to go over this more in class. Anytime you have a variable in the denominator, like here we had a t in the denominator, our denominators can't be 0. So once we get our answer, we would want to make sure that that answer doesn't make the variables in the denominator, make the whole denominator of that term 0. Otherwise, we wouldn't be able to include it in our solution, which we'll go over that more in class. I think all the ones that I picked out for this lecture work out nicely, but I did want to note that. Okay, so let's look at our next one. Our next one, first of all, we need to find our least common denominator. So I look at my first two denominators, 4 and 5, common denominator would be 20. And then I look at my last one. It's just a regular number, right? It's just a constant 15. So if I wanted to see a denominator, I could write it over 1. But not necessary, because since the denominator is only 1, any common denominator I use will work, because 1 goes into everything. So here my common denominator is just going to be 20. So just like before, I'm going to multiply every term by 20. So x plus 2 over 4 times 20 minus 20 times x minus 1 over 5 equals 20 times 15. Now I have to be a little bit careful for two reasons. One, we have a subtraction. We can't lose that term on the that sign on the second term. Second of all, we have quantities on top, which means after I reduce, if there's anything left over, I have to reduce that distribute that leftover to each term in the quantity. So, for example, on the first one, we all know that 4 goes into 20 5 times. Now, you could go ahead and do this in your head, I suggest writing it out as one more step. I have the 5 left over from when I reduced, and then on top I have this quantity. It's still in parentheses, so that means I'm still going to be multiplying. So I will have to distribute that 5 to both terms. Okay. Same thing on the second term, 5 goes into 24 times. Don't forget about this negative, the subtraction. So that leaves me with a -4 times the quantity that's left in my numerator, which is x minus 1. And then on the other side, nothing cancels, and 20 times 15 gives me 300. Okay. And from here, I can go ahead and simplify. I'm going to distribute the 5 to both terms, which gives me 5x plus 10. Then I'm going to distribute this 4 to both terms. Remember, the negative goes with it. So -4 times x gives me -4x. -4 times -1 leaves me with a +4. Okay. Then I combine like terms, so 5x minus 4x leaves me with just 1x, and 10 and 4 gives me +14. Last thing I need to do is just move my 14 to the other side so that x is isolated. Since I'm adding it, to move it, I need to subtract it, which leaves me with 286. Okay. All right, let's look at another one. Okay, so on this one, same idea. I find my least common denominator first. Now notice here, it's a little fishy, we have variables in our denominator. Anytime we have variables, we have to think factors. What are the factors of each denominator? Now here, both of these are factored completely, so that's good. But this is a quantity. I can't break up that quantity. I can't say, oh, this one has 3 x's and this one has 2 x's, so how many x's do I need? Because that 3x is stuck like glue to that 2 with the plus sign. So 3x plus 2 has to be in my least common denominator, just like on the other side, 2x has to be included in my least common denominator. So that means my least common denominator in this case would be 2x times the quantity, 3x plus 2. So that's what I'm going to be multiplying by on both sides. Some of you may have learned cross multiply. That's fine. That only works when you have one fraction on each side of the equal sign, and the reason we can cross multiply is because of what I'm doing here with the clearing fractions. I'm going to multiply by 2x and 3x plus 2 on the left hand side, so 5 over 3x plus 2 is equal to, I'm going to multiply 2x times 3x plus 2 by the right hand side, which is 3 over 2x. Then just like before, I reduce my fractions away. So here I can cancel my 3x plus 2's, and I'll be left with 2x times 5. On the other side, I can reduce my 2x's, which leaves me with 3x plus 2 times 3. Okay? And then from here, I just go ahead and solve by simplifying. So 2x times 5 gives me 10x. On the other side, since there's a quantity, I have to distribute that value into each term of the quantity. So 3 times 3x is 9x. 3 times 2 is 6. Then I move my x's all to the same side. So minus 9x leaves me with just 1x is equal to 6, which would be my solution. Okay, so you will now be able to do your E1.6 quiz in my math lab, which again is reducing versus clearing fractions, not reversing. Reducing. Sorry about my typo. There is this worksheet at the end. You are not required to do it. If you want to do it for extra practice, you can, but you don't need to turn it in or submit it to me in any way. Okay?